Let us create a red black tree for the set of keys, and simultaneously I will show you 2 3 4 tree. So let us insert first node. As it is a root node, 10. A new node should be a red node, but this is a root node, so that's it will be a black color node, so 10. Then here 10. 2 3 4 tree. Now next key 20. 20 is greater than this one, so it will come as a right child, and it is in red color. Every new node is red color. So when a new node is inserted, and if parent is black, then no problem in red black tree, right? Then this means what? It is on the right side of 10 in the same node. So 20 comes here. This is 20. Perfect. The next 30. 30 is greater than this one, 30 is greater than this one. So these two we have inserted, 30 I am inserting now. So 30 is inserted here as a red node. Now this is red conflict, red conflict. This is a new node, right? And this is parent, and this is grandparent. This is a uncle, right? So parent is red but uncle is black. So what to do? Rotate. Which rotation is required? RR rotation or left hand side rotation, or zig rotation, whatever the name you like, you can take it. So how it looks like, see, this 10 will come down, okay, and it will become red color, and 20 will move up and it will become black color, and 30 comes here, that is red color. So these are the changes. So I'm not drawing a new tree now, I'm making modifications to the same tree. Now this means 30 is inserted here, so 30 is inserted here. Already I have shown you that a single node is having 3 values. So this is middle node is black and left side is red, right is red. So this means these two reds are as a part of the same node. Now next key is 50. So where it will be inserted? Here, 50. Red conflict. So what we do here, this is new node, and this is parent, and this is grandparent, this is uncle. This is red and uncle is also red. So what to do? Change the color of parent and uncle to black. So these two should become black. Right? And grandparent should become red. But as it is root, after making, if I make it red also, actually it's a root. So again convert it back to black. If it was not root, we would have kept it red only. This is the result after inserting 50. Okay, so we have this node and 2 new nodes, and 50 is a part of 30. Let us see how it happens in 2 3 4 tree. So when we want to insert 50 comes here, there is no space for 50. Then what we do? We split this node, right? Then what we can take on this side? So out of these 4, 10 will be on this side, then 30, 50 will be on that side, and the parent will contain just 20. So if you know about this insertion in a 2 3 4 tree, it's better. So already I told you that if you have not seen it, just go and watch it. So splitting is done. We have done splitting, right? So 50, there was no space, so we have splitted. 1 node this side, 2 node that side, and this 20 goes up. Check it. 20 is a separate node, black color. 10 is a separate node, black color. 30 is a separate node, black color. 50 is a part of same node, red color. This is matching with 2 3 4 trees. The next key is 40. 40 comes where? 40 comes as a left child of 50. Now this is red conflict. This is a new node, and this is parent, and this is grandparent, and this is uncle. And parent and uncle, if you check the colors, this is red and this is black. So perform rotation. Which rotation? This is zigzag rotation or RL rotation. So what happens, as we know about the rotation, 40 goes up here, and 30 comes down as a red color node, 30, and 50 remains as a red color node. This is how it looks like, right? So it means when we are inserting 40, where 40 should come? In between these two. When it is in between these two, just move 50 here and insert 40. Now what that note says? that 3 keys in a single node means what? One of them is black, middle one is black, and this left side and right side are red. Yes, left side and right side are red. So it's completely matching with that 2, 3, 4 tree. All 3 keys together in one node. So these two red says that we are part of 40. So 40 is in the middle there. That's it. Now next, after finishing 40, let us insert 60. 60 comes here. Red-red conflict. Red-red conflict. So what we did here in red-red conflict, this we made it as, because this is red and uncle is also red. So recolor them, make them as black and make this as red. Make this as red. 40 as red. Got it? So we want, now check this one. Is there any red-red conflict? No, this is red-black. This is perfect. So already we know this. So this is red and this is black, so there is no conflict. So this is perfect, right? This is balanced. Now what happens here? Let us see. When I want to insert 60, there is no space for 60. Then what to do? Split that node. Okay, split. Then after splitting, what happens? When we have splitted, 40 will go up, right? And 50 and 60 will go as right child of this one, right child of 40. So this is how splitting will done. I will redraw this 30. I'll take some space here. Okay, 30. See, 30 and 40 and 50 were there. So when we want to insert 60 also, there is no space. So we split and 1 key on this side, 2 key on that side, and middle. Actually, it's not exactly middle. So right bias this is. So 40 goes up. So now what this says, see, first node, black color. 40 is a part of that, red. Black color, red. Then this is having left child, separate node, black, separate node, black. This is separate node, black. So this is separate node, black. This is 50, separate node, black, separate node, black. 60 is a part of 50. 60 is a part of 50. Now next key, that is 70. I will insert 70 now. 70 will come here, right? 70 will come as a right child of 60 and it will be red-red conflict. So red-red conflict means this is red, uncle is black. So perform rotation. So 50 comes here, okay, and 60 moves up and this becomes 70. This node is gone. This is how it's look like. Rotation is done, zig-zag rotation or RR rotation. So same way, when I am inserting 70, 70 should come here. Now what that node says, there are 3 keys. Now the node belongs to 60, 50 is left and 70 is right. So all 3 in same place, 60 in the middle, this is red, saying that we belong to 60 only, same tree. Now next 80, 80 should come on the right side of 70, 80 is inserted here. Now red-red conflict, red-red conflict. Uncle is also red. So change this to black, black. Then what about grandparent? Should become red. Again red-red conflict, red-red conflict. Then check uncle, uncle is black. So perform rotation. So I will redraw it. So we have to perform rotation over these 3 nodes. So I will redraw it. 40 comes here, 20 is on this side and 20 should be red. Right, 20 should be red and this 60 should be red. 10 is on the left hand side, okay, and 60's right side is 70 and 60's left side is 50, that is black color only. 30 was left of 40, it should come as right of 20, black color only. Then 80 is red only on the right hand side of 70. This is the final tree. Now I will show this there. I'll show this there. Now when I am inserting 80 here, there is no space. When there is no space, I have to split that one. So I will take this as it is. I'll take this as it is. 10, okay, 30. I'll split that. So splitting this one. 50 on this side, 60 we will send it upwards, and these are 70 and 80. 60 I have to take it upwards. So 60 will go here in this node. Is there any space available? Yes, 60 can comfortably fit in here. So 60 is here. This is left of 20. This is after 20 and before 40. After 40 before 60. This is after 60. This is how it looks like. Now what this tree says. First node, 3 keys. 40 is black. 40 is black. 20 and 60 are part of same node, red. Left and right red, left and right red. Separate node, 10, black color. 10, black color. All 30, 50 and 60, 70. Sorry, this should be 30. This was 30. I made it 40. 30, 50, 70. 30, 50, 70, all black. Now 80 is along with 70. So it's red. Exactly matching. So this is how red black trees are related to 2, 3, 4 trees. Now if you practice this once, you will never forget red black trees. Now you don't have to memorize properties of red black trees. You know how they are designed, you know the main idea behind them, right? So you can gather the concept once again easily. If you are familiar with the 2, 3, 4 trees, that is sufficient. You can recall everything from about red black trees also. Now remaining keys 4 and 8, you do it. So I have shown you sufficient number of keys insertion. Now you know how to create a red black tree and how it is related to 2, 3, 4 trees. So that's all in this video. Practice this one by yourself.